Good morning, ladies and gentlemen. Friday, finally, last day of classes. Very exciting. So today, like I said, because we finished the new material yesterday, today is going to be essentially a review period. So I have some people that have been posting on the classroom on that post saying the questions that they'd like to go over. I have a couple of things that I personally would like to go over as well, just to clarify some things from what I was noticing on assignments and other things, and SIP props and stuff. So take a minute now just to go over some of that stuff. Take a look at the questions for review. So if you look here, we have the post, the questions for review. So far people have started to post some stuff, which is fantastic. I have those all written down to go over. And like I said, there are a couple of problems that I personally would like to go over as well. So take a minute or two now while I'm setting up and go over that stuff. Okay. All right. All right, so we are ready to go. I will start off with the things that I wanted to review, and then I'll hit up those questions that were asked. And after that, I'll keep asking for questions. Time permitting, we'll go over as much as humanly possible. Just on a side note, things to remember when you're preparing for the exam. So first of all, you need to be making your memory aid ASAP, like this afternoon if possible. After your memory aid is finished, then your job is to complete as many problems as possible between now and Tuesday. So starting with the assignments, going over handouts, doing the review exam problems. On the same folder as the review exam and solutions, I added some review on triangles and trig and system of equations. Okay, so just some review for that, because you do need to be doing that, and angles and stuff, and some problems to go with them along with the solutions. So you have the triangles one, two, systems, triangles and trigs, so with the solutions. So you have all of that going on for you to practice. So that's the review stuff that we didn't cover together. Everything else we did cover together, or I gave you the notes at the same time. So like I said, your goal is to get as much exposure as possible to as many types of problems as possible. And since you have all the solutions, you can check your answers as you're going. I want to look at two things before we get started. Okay, this type of problem. These are brackets, so I need to do what's on the inside first, okay? So 3, 5, 8, 9, divided by 2,000. That gives me 1.7945, okay? These brackets mean greatest integer bracket. So when I take a number out, it has to be the greatest integer. What is the greatest integer of 1.7945? It's 1. Your calculator does not do this for you. So you have to manually do this. Yes, you can do 1 divided by 2,000 times the number. That's fine too. But this step here has to be done by you by hand. Another example, let's say 5 over So if we're doing this one, again, we would do this on the inside. Let's just make this a little easier here. Let's take away this 2. So this gives me negative 3.87. This comes out as negative 4. And then this gives you 5. The reason this is so important, I have a comment on the side that says I completely forgot to do this on the exam. That's their word. You are not alone. Okay. The reason I'm stressing this is because this type of problem can come up in one of 3 ways. It can come up as a part A. If it comes up as a part A, they're going to give you this one, which is wrong. But they're going to give you this answer. As a possibility and this answer. Sorry, this should be a positive. So they'll probably give you both just to trick you. Literally just to trick you. And there's nothing I can do about it. If you give me this answer on a part B, because you forgot to do this step, 4% down the drain. It's not negotiable. There is no wiggle room for a part B question. So if you get this in a part B and you forget to take the greatest integer, 4% of your exam is gone. If you get this in a part C, you will still lose marks, but it's not as drastic as if you get it in a part B because you still can get part marks for whatever work you did do. This needs to be clear. Is this clear for everybody? Way too many people forgot this step. Okay, so make sure it is clear. This type of thing comes from practice. If you are practicing the problems, you would have gotten used to this step. So what this tells me is not everybody is taking the time to go over the assignments and go over the handouts. I'm not talking to everybody right now because I know there are people going over the assignments. I'm seeing the same number of people completing them and submitting them on a regular basis. But for those of you who are not, it's really important to do that. Don't spend 3 weeks in summer school learning to end up not practicing enough to pass your final. Or not do as well as you would like. The other thing I would like to clarify is this. This is metric relations, okay? What do we notice? So you may have something different for your formulas here. Q, P, R, I don't care. I don't know. It depends on your teacher. I use A, B, H, M, and N, and C. Some people don't. So however you label it, your formulas are going to be identical, just with different letters. That's fine. Now, what is important is this. The trick is, a lot of people see this, like a triangle that's cut, and you have this thing here, and they say, oh, this is metric relations, but they don't have this. And as soon as you don't have this, these mean nothing. They don't exist. The relationships do not exist. So in order for you to use metric relations as a tool, you have to have this right here. The 90-degree angle at the top. Is this also clear for everybody? I can't answer that. I can't go over the situational problem. So it's just a clarification. Everyone good with this? Okay. The last thing that I want to go over myself that was on my list before I start with your list is what we call a conjecture problem. So some of you may have seen these and some of you may not have seen these before. This is handout 6, number 51. So this is a very specific case of problems. Sometimes they like to use it, sometimes not. This is kind of like, this is one of the toughest level of problems that you can get, but sometimes they do come up. Toughest in the sense that you're not used to doing this type of problem. They're not necessarily, the calculations aren't necessarily hard, and we're going to see in this problem, these calculations are not hard, but if you're not used to doing this type of problem, it can be tricky. So you read over the problem. Line segment DE is drawn such that the coordinates are 0, 24, and 24, 0. A point P is chosen on line segment DE, but P is not one of the endpoints. So it's not the same as D or E. See, we have two different case scenarios here. Line segment PR is drawn perpendicular to DE with endpoint R on the axis. So that just gives you two pictures describing the situation. Formulate a conjecture. So you'll actually see them say formulate a conjecture. When you're formulating a conjecture, you are testing 3 cases to find a relationship. I'll get to your question in a minute, Leo, okay? So when I say 3, this is non-negotiable. 3 cases to find a relationship. The tricky part of this is you are making up your cases based on the information you have. So we have that P is on the line. We have that PR is perpendicular and that R is the x-intercept. So what I'm going to do is I'm just going to play around with P, and then I'm going to find R based on that. So I'm going to do this 3 different times. So the first thing I need to know is the rule for DE. So slope is y2 minus y1 over x2 minus x1. That gives me 0 minus 24 over 24 minus 0, which is negative 24 over 24, which is negative 1. So the rule is negative x plus 24 This 24 coming from this point here being the y-intercept. Now we're going to take 3 cases for P. Case 1, P, make it up. Pick a number. Pick an x coordinate and find the y. I'm going to pick x has to be between 0 and 24, so maybe I'll choose 22. So I need to find, knowing that it falls on this line, I plug in 22 as my x, and this gives me 2. So P is at 22 and 2. Now I need to get line PR So it is perpendicular. So the slope is the negative reciprocal of this, which is positive 1. So I have x plus b. So I have 2, 22. This moves over to give me negative 20. So the rule is x minus 20. And then I'm finding point R. So point R is the x-intercept, which means y is 0. I move the 20 over. So the 20 is x. So R is 20 and 0. So what I am doing, they say formulate a conjecture. We need the relationship between the x-coordinate of point R and the coordinates of point P. So we have 22 and 2, and we're comparing that with 20. So this is xp, yp, and the xr is 20. What do you think we can do with these two numbers to make 20? Well, if I take 22 minus 2, which is the xp minus yp, that gives me the 20. So I've seemed to have found a relationship, maybe. So I test it again. Case 2. P is, I don't care, 15. Want to do 15? Let's do 15. Sure. Okay. Unless anyone has a better suggestion. So I do the exact same steps. Y is negative 15 plus 24, because that's the rule. Y is 9. So P is at negative 15 and 9. Positive 15, duh. PR, y equals positive x plus b. So I have 9 and 15. And if I move this over, 9 minus 15 is negative 6. So y equals x minus 6. Point R, y equals x minus 6. We have 0 as y. So 6 is my x. So again, I'm comparing the x coordinates, the x coordinate of R, which is 6, and seeing how these two compare. Well, this is 15 minus 9, which is xp minus yp. Now I have to test a third case. You will not get full marks, even if you get this relationship right. If you haven't tested it 3 times, you won't get full marks. So just pick another one. I'll pick x is, what did I do this time? 22. I'll pick x is 3. y equals negative x plus 24. We're plugging in the 3. So we have 3 and 21 are the coordinates of P. PR, y equals x plus b. 21 equals 3 plus b. If you move this over, you get 18. So the rule is y equals x plus 18. R, we need y to be 0. So negative 18 is the x. So r is negative 18 and 0. And now we test to see if our relationship works. So we have 3 and 21, which is xp, yp. And we have xr, which is negative 18. Is this equal to 3 minus 21? Yes. So that's xp minus yp. So our relationship, after testing it 3 times, is that xr is going to be xp minus yp. This is worst case scenario. It is definitely possible you won't get this, okay? But there's a slight possibility that you could. The problem with these problems is you can't necessarily practice them because they're all so different. So the key to this type of problem, if you see formulate a conjecture, you look at what relationship you're looking to find. So they said a relationship between P and the x coordinate of R. So I had to find 3 different cases with 3 different P's and 3 different R's and compare them. And you have to do it 3 different times. Like I said, this is worst case scenario of a problem that you can get. You figure out what they're asking for and you test 3 different cases. From there, you make your relationship. Even if you've tested 3 different cases but you can't find the relationship, you'll still get a whole bunch of marks. So worst case scenario, you get a conjecture, just make up numbers. That's the part that actually is trickiest. It's the easiest in the sense that you make up whatever you want, but it's hard because you're not used to making up whatever you want, so you don't tend to do it. So if you see the word conjecture, you're making up 3 cases. Okay? And fingers crossed it's not, but you never know. That's the problem. Hope for the best, prepare for the worst. Right? That's the spirit. All right. Okay, so now I'm going to look at so I have assignment 5, number 1, 14, number 2, question 12, assignment 12, question 1 and 2, and a review of Venn diagrams. So let's get started on that. We'll start with assignment 1, assignment 5, number 1. Have we done this one already in class? Does anyone remember doing this already? We have done this already. That's what I thought. So since we've done this question already in class, I'm going to save it till the end. If there's another question similar to that, I'll go over it like in the handouts, but I don't want to spend time doing the same questions that we've already done because you can watch the videos, okay? So Emily, you're the one that asked me that question. If there's a question on the handout that's similar to that one, that you'd like to go over. I'd rather go over that than go over when we went through. Okay, so maybe just find a question that's similar on the handout, or maybe I could even do that right now. Hold on, let's do that. So that would have been class 5. Right, your question, Leo. Your memory is your memory aid. If you started one for the SIP prob and you just want to build on that, that's fine. If you want to make a whole new one, I don't care. I would never know the difference. As long as your memory aid follows the rules, meaning it's one sheet double-sided and it's handwritten and it's a standard piece of paper, then I really don't care what you do. Highlighters, colors, however you want to organize it, however you want to do it, it's up to you. You need that stuff and everything else. So if you remember, when you go here in the notes, you have the course outline, which we went through, and it has all the different topics. So you can check this through, okay? To make sure you have all of that on your memory aid. We could do a couple of rational expressions problems to review. Can't spend an hour and a half on rational expressions, but we can review some. Am I going to take your memory aid? It depends on what the instructions are. If the instructions on the booklet say I need to take your memory aid, then I'll be taking your memory aid. If they don't say it, I won't. Let's try number 27. All right, so this is a multiplication and this is a rational expression. And we remember that the first thing we do with rational expressions is we factor. So this top is factored. On the bottom, I can pull out a 3, leaving me with m minus 5. I'll do one with division in a second. I'll do one with each, okay? So then I can pull out an I can pull out an 8, leaving me with m minus 1. For this one, if you remember how to product sum it, we could do this on the side. So product is negative 10. So we have 1, 10, 2, and 5. The sum is negative 9. Bigger numbers are negative. So we have, I did not mean to circle it that way. Negative 10, negative 5. So we have this case. So this becomes negative 10m plus m minus 10. And we group. So here I can pull out an m. Here I can pull out a 1. So I get m plus 1 and m minus 10. If they say the denominator, given the denominator is not equal to 0, you don't have to do the restrictions. If you do, then you do the bottom. 1, 2, 3. 1, m minus 5 equals 0, so m is 5. 2, m plus 1 equals 0, so m is negative 1. And 3, m minus 10 equals 0, so m equals 10. So the restrictions in this case are m cannot be 5, negative 1, or 10. Okay. Once we've done that, we just go here and we start a canceling game. So I have here, these go away, and I have here, this goes away with this. So what am I left with? On the top, I just have the 8, and on the bottom, I have the 3m minus 5. Okay, we'll do a division one, and hopefully that'll answer your question at the same time, Kayla. Okay, is this good? Okay. So we have this division. Our first move is to factor. So 10x squared minus 28x plus 16. What do we get? So I'm going to save us some product sum time. So we get minus 8x minus 20x plus 16. Here I can pull out a 2x, and I'm left with 5x minus 4. And here I can pull out a negative 4, leaving me with 5x minus 4. So I get 2x minus 4 and 5x minus 4. And this actually turns into 2x minus 1, 5x minus 4. So we have this here, minus 2, sorry, 2. We have 2x minus 2, 5x minus 4 over 2x minus 2. Then we do these two. Okay. So here I can pull out a 5x, leaving me with 5x minus 4. Here I can pull out a 1, leaving me 5x, negative 1, leaving me with 5x minus 4. So this goes 5x minus 1, 5x minus 4. And we'll do this one here, 5x squared minus 41x plus 8. So this one splits into minus 40x minus x plus 8 when you're product summing. So I can take a 5x out of here and I'm left with x minus 4. And here I can take out a negative 1 and I'm left with x minus 4. 5x minus 1 and x minus 4. Lots and lots of stuff there. So I have 5x minus 1 and x minus 4. Oh, 8, duh. Minus 1? Because here you pull out a minus 1. So now what I want to do is I want to change this to a multiplication. And I flip this second fraction. So where do the restrictions come from in a division? The restrictions come from the denominator of the first one, the denominator of the second one, and the numerator of the second one. So at the end of the day, it doesn't matter if you do them before the flip or after the flip because you're including everything that's in this side of it. Okay, so just on the side, 1, x minus 2 is 0, so x is 2. 2, 5x minus 1 is 0. 5x equals 1, so x is 1 over 5. 3, x minus 8 is 0, so x is 8. 4, 5x minus 1 is 0. So we already solved that, so we know x is 1/5. And then we have 5x minus 4 for number 5. So 5x is 4, so x is 4 over 5. So all of the restrictions are that x cannot be 2, 1/5, 8, or 4 over 5. So I go here and I play my canceling game. 5x minus 1, x minus 2. The 2's go away, and the 5x minus 4 goes away. So on the top, I'm left with x minus 8, and on the bottom, I'm left with nothing. So this is what I'm left with. Questions? For division, it's numerator and denominator of the second one. So notice here, I didn't touch this one of the second term. So notice I didn't touch this at all. I took it from the bottom of the first and the entire thing that's after the division sign. All of them. Yeah, so the term you're dividing by, that's you take everything there to make a restriction. Ah, almost dropped my pen. All right. I doubt there's going to be 3 on the exam. But nothing changes if there are 3 or if there's not 3. That just means you get to cancel from a third group. Like if you had, for instance, x plus 4 over x minus 3 times x plus 5 to x minus 1, x plus 4, x minus 4 divided by x minus 3, x plus 5. Okay. So the only thing that changes is you'd have restrictions, you'd have more restrictions. This would change again, that flips. And then you just play a canceling game. So the +4, the -3, the +5, and I'm left with 2x minus 1 over x minus 4. So that's the only thing that changes if there are 3. I can, in fact, do that, Kayla. Lovely, lovely. Adding and subtracting. Where did you go? Okay. All right, so this is already factored. Well, it's actually not. I just lied. Don't listen to me. Well, please do listen to me, but not for that specific thing. Okay, so now we're comparing denominators. So here I have a 3. This one doesn't have a 3. So it needs a 3. This one has an x plus 1. This one doesn't. It also needs an x plus 1. Now this one's good to go. This one has an x plus 5. This one does not, so it needs it. Okay, so fraction number 1 becomes, it's a horrible line. I distribute these in, so I get 2x squared plus 10x divided by 3x plus 5, x plus 1, minus, these get distributed in, but this turns into a 6. So I get 6x plus 6 over 3x plus 5, x plus 1. So then I just, because I have the same denominator, remember when we add fractions, we just recopy the denominator. And then I have 2x squared plus 10x minus 6x minus 6. Now you're just going to rework the top to see if you can make it nicer. So you get 2x squared plus 4x minus 6. And you're like, oh man, I can totally factor that. Nastiness. Oh, 2x squared plus 4x minus 6. You can pull out a 2. And this actually factors into, so this is like worst case scenario where you have to do a whole bunch of stuff. And then, and only then, the entire top is a multiplication. The entire bottom is a multiplication. I can cancel these out. You cannot, I'm saying this loudly because you cannot cancel it here. Makes no sense. You can only cancel if the whole thing is multiplication over an entire multiplication. Okie dokie. All right, fantastic. So, go back to the questions. So that takes care of that. Assignment 12 and assignment 14. We'll start with 12. 12, number 1 and number 2. Bag contains marbles of 3 different colors, green, red, and blue. In the bag, there are 6 more green marbles than red marbles. Twice the number of red marbles is equal to the number of green marbles increased by 8. There are 2 blue marbles. So let's start there. Before I can do anything, I need to find out how many marbles there are anyway. So I could call this, if I call X red, I'll do this in black, that way we're not confused. X is red marbles. Y would be green, not Y. We know what green is. There are 6 more green than red. Twice the number of red marbles, is equal to the number of green marbles increased by 8. So I can just solve this. 2x equals x plus 14. Bring this over. X is 14, which means there are 14 red marbles and there are 20 green marbles. And there are 2 blue. Now, a game involves randomly drawing a marble from the bag after placing a $3 bet. There are 3 outcomes. All right, so we make our table. Before we even make a move, I'm going to make my table. 1. So I have outcome, probability, net gain, product. So my outcome is green, red, blue. They ordered it that way. Green, red, and blue. Well, I just figured out the probability, but I need to know the total number of marbles. So the total number of marbles is 14 plus 20 plus 2. So there are 36 marbles. So the probability of getting a green is 20 over 36. The probability of getting a red is 14 over 36. And the probability of getting a blue is 2 over 36. If we have a $3 bet, if they win a green marble, they receive $3. So I bet $3 and I get $3, so nothing happens to me. If a player draws a red marble, they receive $1. So I get $1, I've paid 3, that gives me a -2. And if a player draws a blue marble, they receive $15. I received 15, but I paid 3, so that gives me 12. My product here, 20 over 36 times 0 is 0. 14 over 36 times -2, -28 over 36. 2 over 36 times 12 is 24 over 36. So now, since the question is this game fair? You calculate the expected value, which is the sum of the last column. So I have 0, I have -28 over 36, and I have 24 over 36. What this gives me is -4 over 36. I don't even care what the number is. This is negative. The game is to the player's disadvantage. Is that clear for everybody? Yep, I will. That was question 1. We'll do the question 2 now. Okay, 2 questions here. If the game is fair, wouldn't you make the equation equal to 0? Yes, but it doesn't say that the game is fair. It's asking if the game is fair. So in the next problem, it'll say the game is fair, and then we're going to make it equal to 0. But in this case, the game is, we don't know, so we have to figure it out. So those are the 2 different kinds of problems you get. Either you have to figure out if the game is fair, or you have to figure out a missing value given that the game is fair. If it was a positive number, again, it doesn't matter how big, how small. If it's a positive number, that means that on average, I would expect to earn money, which means it's to the player's advantage to play this game. Make sense? So, all right, a game of chance. A flashing dot moves over a wall screen. The screen is rectangular and gray. On the screen, there is a white right triangle, namely triangle QRS, represented below. A player must bet to play this game. So it's basically either it stops in the white section, the pointer, or the gray section. So we need to figure out the probability of each of those things. Now, the probability of white is going to be the white area divided by the total area. And the probability of the gray is going to be the gray area divided by the total area. So we need to figure out the probability of the white and the probability of the gray. So we're going to start with this. Now, here I see that this has the right angle up here and the right angle down here. So this is metric relations. You can use Hero's formula, but there's a very, like there's a lot simpler way. So A, B, M, N, H, and this is C. So my M is 36. My N is 64. My C is going to be the addition of these. Hero's formula is for any triangle. It's just with a right angle triangle, it's easier to use base times height divided by 2, right? But Hero's formula will still work. We're not going to use it, but it will still work. But that just creates, like for us here, if we're finding the area, Hero's formula creates an extra like 4 steps for us that we don't really want to do. But you can if you're stuck for sure. So when I'm calculating the area of this triangle, I need a base and a height. So either I need H and C, or I need A and B. Well, since I already have C, let's just see if I can get H. Well, H squared is MN. So H squared is 36 times 64. H squared is 2304. And I square root it to give me 48. So the area of the triangle is base times height divided by 2, which is 48 times 100 divided by 2, which is 2,400. So that's the area of the triangle or the area of the white. We now need the area of the rectangle, which is length times width. So in that case, I have 80 and 150. So that gives me 12,000. So the area of the shaded is 12,000 minus 2,400. And that gives me 9,600. So the probability of white is 2,400 divided by 12,000. This reduces to 1 over 5. Probability of shaded is 9,600 divided by 12,000, which is 4 over 5. Everyone good with what I did here? Okay. Now that we have that, we can start to deal with our game. So we have to make our table. Outcome, prob, net gain, product. So I have shaded and I have white. The probability of me getting a shaded, I just said, was 4 over 5. And the probability of me getting a white is 1 over 5. So now we go back up to the problem and we find out what our net gain is. So it says a player must place a bet. We don't know what it is, so we're going to call X our bet. If the flashing dot stops in the white section, you get $10. And if the flashing dot stops in the gray section, you do not get any money. So if it stops in the shaded section, I don't get any money, but I paid X dollars to play the game. So I'm actually losing whatever the bet is. So my product is 4 over 5 times negative X, which is negative X over 4X over 5. If I land in the white area, I get $10, but I still made a bet to play this game. So whatever I get minus what the $10 minus whatever I bet will give me my net gain. So then I get 1 over 5 times 10 minus X. That gives me 10 minus X over 5. Now it says the game is fair. So again, you get points for writing this. So I get negative 4X over 5 plus 10 minus X over 5 is equal to 0. I do my denominator trick because I had kept the denominators the same. So this 5 goes away. I get negative 4X. That 5 goes away, so I get 10 minus X, and 0 times 5 is just 0. The X terms go together. Yes, this will be on YouTube. So this moves over, and I divide by 5 to give me X is 2. If you have any questions or you just want me to slow down a bit, let me know, okay? I know I'm going a little fast, but I'm really just trying to cover everything that we can. But everything's on YouTube. Questions on that? Okay. Assignment 14, number 2. Get it out of my way. You have two case scenarios. Expected value, okay? If the game is fair, it's 0. If the game is not fair, then the expected value will be positive or negative. So if the game is fair, that means on average, I would expect to break even completely, which means it's a fair game. If it's not 0, then it's not fair. And it's either to the player's advantage, meaning on average, you would expect to earn money from this game, or it's to the house's advantage or the player's disadvantage, meaning that on average, I would expect to lose money. So if the expected value is positive, that means the player expects to earn money from this game. So it's advantageous for me to play, so it's the player's advantage. If it's fair, break even is 0. If it's negative, that means on average, I would expect to lose money. And losing money means it's not to my advantage to play, which means it's to my disadvantage. Okay. Each student in a class of 33 students was assigned a Z-score for his or her mark in mathematics. Julie, Melanie, and Karen are in this class. The following table shows Julie's marks and Melanie's marks and the Z-scores associated with each of these marks. So let's just start off with that, Julie. Z is her score minus the mean over the standard deviation. So she has a mark of 60 and a Z-score of negative 1.7. And Melanie, I want to say Mark, but it's Melanie. Has a Z-score of 2 and his score is 97. You have two equations, two unknowns. What do? System of equations. So I'm just going to put this as X and Y just to make it a little bit easier to see it. And make it something that you're used to. So if I switch these in both, I get y equals 60 minus x over negative 1.7. And here I would get y equals 97 minus x over 2. So now I can use comparison. So 60 minus x over negative 1.7 is equal to 97 minus x over 2. Cross multiply. 60 minus x equals negative 1.7, 97 minus x. So here from the 2, you get 120 minus 2x. I'm just doing it to make it easier for you, but you could leave them. That's fine. As long as you know that whatever you solve for x is actually the mean and y is actually the standard deviation, then you can do that. Doesn't matter, as long as you're consistent with your notation. So here I get negative 164.9 plus 1.7x. So I'm going to do a switcheroo. The x is coming over here and the number is coming over here. So that gives me 120 plus 164.9 equals 2x plus 1.7x. So I get negative 284.9 equals 3.7x. Positive, positive, positive. And so x, which is actually the mean, is 77. So I go back to one of these, and I have 2 equals 97 minus 77 over the standard deviation. So 2 is 20 over the standard deviation. If I switch these, I get that the standard deviation is 20 over 2, which is 10. Now I go back to the top and it says Karen obtained a mark of 80. So now we have the standard deviation and we have the average, so I can find Karen's z-score. So she got an 80, the class average was a 77, and the standard deviation was a 10. So this gives me 3 over 10, which is 0.3. So that is her standard deviation. How did I find the standard deviation? Once I had the mean, I went back to this equation and I plugged in 77 as the mean. And then because I only had one variable, I could just solve this up. So I plugged it in here. So the x bar became the 77, and then I just switched these and gave me 10. All good?
Oh, whoops, sorry.
Sorry? We good to go? Okay. God is speaking. Yeah, just default to the population. For this, it doesn't really matter. For the other one, it does. But if it doesn't say, then you just say it's the population. Oh my gosh, you're a big pain here. All right, there we go. This pop-up's driving me crazy. Okay. Oh my God. Finally. So the question, the last thing was a review of a Venn diagram. So I'll do an example of a Venn diagram. Things are taking their time to open here. So as I'm opening this, a quick review of a Venn diagram was the last thing that was asked. So take this time now. We still have like half an hour. That'll only take us like 5 minutes. So we still have half an hour. So you need to think of things to go over that you would like. Open, please, and thank you. Yeah, I can do a couple of quick radical examples. Yep, so that's the same thing, right? So I'll do that. Whenever the computer decides that it wants to start working again. I'll do one of each. There we go. I'll do an adding, multiplying, dividing, and simplifying. Quick one. All of those are not Venn diagrams. So there are 75 children enrolled in a music program. 30 of the children are learning piano, 42 are learning guitar, and 15 are learning both piano and guitar. So we'll fill out our Venn diagram. We have our circles. So we have guitar and we have piano. So we have 75 kids total. We have piano is 30, and we have guitar is 42, and we have 15. So 15 in both is where we start. So the 15, oh, sorry, this is on the handout, 11. So if you go to the page that's titled Venn diagrams and probability, it's number 1. So I have the 15 that goes in the middle of this. So if I know that there are 42 and there's 15 in the intersection, so 42 minus 15 gives me 27 on the outside here. I'm going to do the same thing for piano. There are 30 people total. There's already 15 accounted for, so there's going to be 15 on the outside. And what doesn't fit in there, we have 75 minus 27 minus 15 minus 15 gives me 18 that are taking neither piano nor guitar. What is the probability that a child is learning guitar but not piano? So that would be guitar, but not the ones who are also learning piano. So the probability, if we did this just like the actual, if we did this the actual, like with the symbols, it's guitar without piano. But that just gives me 27 over the total, which is 75. And that reduces to 9 over 25. So remembering that to fill in the Venn diagram, you're just looking at what intersects with what and what adds up to what, and then the probability from there is easier. If you just wrote the probability of guitar and not piano, and it's 27/75, and you had shown me this circle too, that would be fine. You can put it in percent too if you want. But like, it depends too. Like, it depends on what kind of problem you get this in. If you get it in a part A, your answer, it's like, it's not your answer. You have to match your answer to their answer. And if you get it in a part B, all I see is the answer anyway. So this would be accepted and this would be accepted. Well, I mean, this would be accepted and this would be accepted. Okay, so because we're still on probability, this part was just asked. I can't do the second part without doing the first part. Okay, so I'll just explain how to go over this problem because it says, is that okay, Kayla, or you actually want me to do the problem? Anyone for doing the problem, or is an explanation enough? An explanation is enough? Okay, so game one, you have a situation where you're tossing a coin. So you're gonna make a table for game one. So you have heads with a probability of 1/2, tails with a probability of 1/2. But you don't know the bet. So for the net gain for tails, you'll have 9 minus x. And for the net gain for heads, you'll have 1 minus x. Game one is fair. So you do your product column. And since game one is fair, you set it equal to 0 and solve for the x, just like we did with the, okay, so it's 7.5. I don't remember. I didn't remember. So 7.5 for it to be fair. Is it? I was going to say 5 for sure. Should be 5. So that's 5. And now it says you're drawing a marble from the bag and you have to bet the same amount of money. Okay. So you have the 3 different outcomes, red, yellow, green. Red happens with 23/100. Yellow happens with 33/100. And green happens with 44/100. So your net gain would be 20 minus the 5. Your net gain here would be 2 minus the 5. And this one would be just minus 5 because you're not getting anything. You make your product column and you add it up. If it's negative, it's to the player's disadvantage. If it's positive, it's to the player's advantage. And if it's 0, it's fair. Make sense? Okay. Okay. So I'm in the radicals handout. So the handout from class 1. So this is handout class 1. Okay, on se calme. Okay. There we go. So this is a class 1 handout. I'm going to do some radicals stuff. It is totally radical. Okay, I'm going to do 14, 19. We'll start with 5. So this is if you have a number. So you start dividing by things that are perfect squares. So 17,496 divided by 4. Yes. So I can write this as 4. There's a 4 in there. Can I divide by 4 again? No. Can I divide by 9? Yep. Can I divide by 9 again? Yep. Can I divide by 9 again? Yep. So I just play around with my calculator. So I divided by 4. I got 4374. I try to divide that by 4, it doesn't work. So I try to divide it by 9, that works. Try to divide it by 9 again, I get 54, that works. Divided by 9 again, that works. So these are all the numbers. The square root of 4 is 2, so that can come out. The square root of 9 is 3, so that comes out. The square root of 9 is 3, so that comes out. The square root of this 9 is 3, so that comes out. And the 6 is 2 times 3, so there's nothing I can do there, so the 6 stays under. And then here I just multiply these numbers. 2 times 3 times 3 times 3 gives me 54 root of 6. Like what kind? Like this one? I don't know what you mean by complex. Yeah, I said I was going to do one of each. One like this, one addition, one subtraction, one multiplication. No, anyways, whatever. You get my gist. 14, multiplication. So I put the two coefficients together. So 2 times 5 is 10. X times x is x squared. Underneath the root, I have a 4. I have an x squared and an x, which I am not going to put together. And I have a y and a y squared, which I'm also not going to put together. So out of the root, this 4 comes out as a 2. This comes out as an x because I divide this exponent by 2, which is just 1. This can't come out, this can't come out, this can, and it comes out as a y. And I'm left with xy here. These go together, so 10 times 2 is 20. X squared times x is x cubed. And the y just stays, and then we have the root of xy. Okay. Division. So I'm just going to start by taking out whatever I can from the top and whatever I can from the bottom. So I can write 125 as 5 and 25. Why do 10 and 2 go together? Because I'm multiplying. This is all multiplying. What's 10 times 2? 20. The x's go together too. Because it's on the outside, anything coefficient goes together. So I can write this one as, I want numbers separated. So 25 is a perfect root, so that's how I want it. And I want the variables to have even exponents. So 10 is even, 6 is even, 5 is not, but I can write it as 4 and 1. 900 I could write as 9 and 10. No, sorry, 9 and 100. The x5 I can write as x4, x. The y3 I can write as y squared y, and the z12 stays. I don't care. Now I'm going to take out whatever I can take out. From the top, the 25 comes out as a 5. X to the 10 comes out as x to the 5. Y to the 6 comes out as y to the 3. Z to the 4 becomes out as z to the 2. What am I left with? 5z. On the bottom, 9 comes out as 3. 100 comes out as 10. X4 comes out as x to the 2. This can't come out. Y2 comes out as a y. Z12 comes out as z to the 6. And I'm left with xy at the bottom. Now, we know that our final answer, so before we even start to play with this, I know that my final answer cannot have a root in it. Okay, so I'm going to take care of this right away. This needs to be taken care of. So since it's a single root with a multiplication, I can just multiply by this. So what this gives me is 5, x5, y3, z to the 2. This goes under one root, 5xyz, over, if I have the root of xy times the root of xy, remember we do this because then it's the root of xy squared, and these things cancel out, leaving you with just xy. So I have 30 x squared y z6 times x times y. And now I can put everything together and start canceling. So this becomes 5x squared y cubed z2 root of 5xyz over 30. I have 3 x's on the bottom. 3 x's on the, whatever, yeah, 3 x's on the bottom. This is a 5. A y and a z to the 6. Y squared. So the 5 and the 30 becomes 1 over 6. The 5 and the 3, x to the 2 on the top. Y to the 3, y to the 2 gives me just y on the top. Z to the 2 and z to the 6 gives me z to the 4 on the bottom. And I have 5xyz here. Because we have z to the 2 over z to the 6. So you have two ways of looking at that. The way I do it as a quicker way is I do big minus little. So 6 is bigger than 2, so I don't go 6 minus 2, which is 4. The 6 is on the bottom, so the 4 is on the bottom. The other way of doing this is saying, well, I do 2 minus 6, which is z to the negative 4, but then this needs to be changed anyway, because the negative is not happy, so it has to go to the bottom and turn positive. I don't know. I don't know. Radicals aren't usually as prominent on the exam. Sometimes they have some, sometimes they don't even. If they do, they're not as complicated. You have to be prepared, but if you're lucky, you may not even have them, or you'll have something very simple. But I can't guarantee it either way. But chances are, if you do have it, it will be simpler than this was. I'd have to check. I don't remember. Usually this is more of a part A, B kind of thing, if anything. So we'll do 1, adding, subtracting. Okay. So we can't add these right away because our roots aren't identical, but this one I can write as x squared times x I can take out this x, it becomes x squared, it becomes a single x on the outside. I can take out this y squared, it becomes a single y on the outside, and I'm left with x here. Now, because my radicals are the same, I just group what's in front of it, 3xy minus 5xy. And now I see if I can put this together. Well, since they're both xy, I can. So 3 minus 5 gives me negative 2xy root of x. What do you mean? Why did the 2 root of x become 1? Remember that when I take an exponent like this, when I'm taking it out, I just divide the exponent by 2. So when I take this out, 2 divided by 2 is 1. Appropriate comments only, please. What? Okay. Oh boy. 10 minutes, people. What do you want to go over? Pick an assignment question. Sure. Assignment 8, number 1. A company calculates the salary of its employees according to the level of seniority. The following are the criteria for determining an employee's salary. 2 complete years of service in the company are required to move up 1 level of seniority. Each level represents a salary raise of $3,000. An employee's entry-level salary is $35,000. So we need to create a rule. So we make our little sketch on the side to just help us create our rule. So I'm going to put X as years, and my Y is going to be my raise. So if I work 0 years, I don't get a raise. I don't get a raise until I hit 2. The variables are from the problem. They're talking about year seniority, and they're talking about raises. You just have to get those out of the problem. It's like a system of equations where you have to figure out the 2 things that are changing. Once I hit 2 years, I get a raise of 3,000. And this goes along here. I stay at 3,000 until I reach 4 years, and then I get another raise, which will bring me up to 6,000 total. So now I see the pattern. So my step is from closed to open, so B is positive. The length is 2, so B is 1/2. A and B are the same sign because it's increasing. So A is going to be positive. What is the difference between steps here? 3,000. So A is 3,000. So if I have this rule, 3,000, 1/2 x. What is the salary of an employee with 15.6 years seniority? So A, X is 15.6. So I have Y equals 3,000, 1 over 2, and I have 15.6. 15.6 divided by 2 is 7.8. This step you do manually. What is the greatest integer of 7.8? 7. So over 15.6 years, he's had a raise of 21,000, but he has a base salary of 35. So salary is 21,000 plus 35,000, which gives me $56,000. B says, what happens if the salary is 89,000? So that's the total. So I'm just going to take 89 and I'm going to subtract the base salary, which is the 35. And that gives me 54,000. So that is the raise that they've earned. So I'm going to plug this into my step function. I divide by 3,000. So here I get 18. Remember, when we're solving backwards like this, we drop the brackets. Here I multiply by 2. So I get 36 as my x. Remembering this is your solid dot. The steps that we have are solid to open, and they have a length of 2. So the 36 is where I start, and I add 2 to get me to 38. What else you got? 5 minutes left. Is there anything you want to see very quickly? Not for me, it's for you. Okay. Well, if there's nothing else, that's fine. Couple of reminders and strategies for the next couple of days. Your memory aid takes priority 1, and then you'll be doing practice problems as much as possible. Okay, so you want me to go over a quick log example? You use log when you get to this point in your equation. When you have something equals something to the x. Now how this changes, if we remember a equals c to the x, that changes x equals log a divided by log c. Base is bottom. Base is bottom. So literally, if I were you, I would do it in colors on my memory aid. Why not? And then C to the X. So that way you know exactly what goes where. So the 16 in this case is the A, so it goes on top. The X here is what drops on its own, and base is 2, so that goes on the bottom. And if you type this into your calculator, your X is 4. Okay. Reminders, memory aid first. Then you are doing as many practice problems as humanly possible until Tuesday. The more problems you practice, the more exposure you get to the type of problems, the more used to them you get. You have tons of resources, practice exams, handouts, assignments, review questions. Do them all as much as possible. Obviously not all, because that would take several days, but that's fine. As many as you can, still having whatever you have to do during the weekend. I'll be giving you feedback on assignment 11 today, 12 and 14 tomorrow. And I'm reachable by emails, and I'll be trying to answer your emails as quickly as possible, especially Monday during the day. I'll be really available to answer your emails, okay? So feel free to email me at any time. Other than that, I'll see you on Tuesday with your memory aid, writing implements, calculator, and photo ID. Photo ID. Anything else? All right, nothing else. So have a driver's license is fine, student ID is preferable. Try to get your student ID from your school, and if you can't find it, then a driver's license or Medicare card is fine. So have a great weekend, happy studying, and good luck, and email me if you need anything. It's emotional. Everyone can do it, just study hard. Have a great weekend.